So now we are going to this response spectrum. So here what we will do, we are going to analyze the setting, and we are going to change this mode combination type. Like if frequency received from model analysis, it is like closely spaced, then this should not be, SRSS should not be there. So instead of this, we can take in from both of the rows and this. So we have changed to rows. Here now we have to insert RS acceleration. So here you can see boundary condition. We are going to change all support, and direction we are going to keep Y direction, and tabular data we have to insert the tabular data like from 0 to 50. These are the acceleration in the form of gravity in Y direction. So we are going to copy and paste. So these are in the form of gravity, so we are going to change this scale factor, and scale factor we are going to put 9.81 here. Okay. So here here we can note like the frequency at a spectral peak of this spectrum is 4 Hz here. So like all modes have less than spectrum frequency. So this means like all modes are in the low frequency region. Therefore, no rigid response or missing mass is needed, and our spectrum result should not be affected appreciably by having captured only 68% of the effective mass in the Y direction from the model analysis. So finally, we are going to insert finally we are going to solve this response spectrum. After solving, we can insert the results item of our choice. So it has been solved. So we can insert here total. We can insert here directional deformation that is in Y direction. Evaluate all results. So you can see the directional deformation in Y axis, that is 0.077 meter. And here we can check. Okay. Thank you for watching.